Hello, this is Tessa Kegel, and this is HBS 5 OHC, Identifying and Controlling Hazards, Mitigation of Health Impacts, Neurotoxicity, and Neuropsychological Issues. And this is Module 8, Part 3. This is the Commonwealth of Australia, Copyright Act 1968, which covers these lectures. The basis of neuropsychological assessment. Lezak, from 1995, defines neuropsychology as an applied science concerned with the behavioural expression of brain dysfunction. It therefore involves interviews, scaled, normed tests, and questionnaires aimed to elicit and evaluate behaviour rather than directly measuring the performance of sensory and motor systems by such techniques as nerve conduction velocity and electromyography. Neuropsychology is a highly specialised area of expertise. As OHS practitioners, it's important that we can both identify when we require this expert assistance and how we can work with neuropsychologists to reduce or manage workers' neurotoxin health impacts. To do this, we need to have an understanding of the basics of cognitive skills areas known as the functional domains of cognition. Casito and other authors have suggested that neuropsychological tests tap into a variety of abilities along a continuum of mental functioning and functional integrity. These range from psychomotor deficits to tasks requiring higher order or more complex mental integration and reasoning. Now, these observed behaviours can be roughly categorised into 6 distinct cognitive skills areas. Psychomotor functioning, which is receiving information from the senses and performing an action. This involves integrating the peripheral nervous system and the central nervous system and is reflected by such skills as motor speed, manual dexterity, and hand-eye coordination. Tests include finger tapping measurements and the Santa Ana dexterity test, in which subjects turn cylindrical pegs through 180 degrees. Attention and concentration. Maintaining awareness over time in order to undertake a task. This is reflected by skills of vigilance, tracking, and orientation. Tests include digit span, or the number of numbers the subject can repeat back in correct order, digit symbol, in which the subject must copy a symbol next to a number according to a code, and trail making, in which the subject draws a line between random numbers and letters according to a particular sequence. Visual cognition. Manipulating and responding to visual information. This involves visual motor, visual practic, and visual constructional skills. Tests include block design or reproduction of a pattern using three-dimensional blocks, object assembly or jigsaw puzzles, Raven's progressive matrices, where the person must determine the correct pattern to complete a sequence, and embedded figures, where the subjects must find a simple design amid a complex pattern. Verbal language. The ability to receive, comprehend, and reproduce language and verbal information. Tests include general knowledge and vocabulary questions, Boston naming test, and naming familiar drawings of objects. Memory and learning, involving the immediate and working memory, short-term memory, and remote or long-term memory in encoding, recalling, or retrieving information. Tests include recall of a story, associated learning, where the subject must remember the matching pair to a word after 3 trials. This can also be done associating patterns and colours, and the Ray auditory verbal learning test, in which the subject remembers up to 15 words over 5 trials. And finally, executive function, including abstract reasoning, perception, judgment, ability to formulate goals, ability to plan or carry out plans, concept formation, organising and generalising. Tests include Wisconsin card sorting, where the test subject must sort cards after deducing the sequence. Porteous maze, where the person must trace the correct path through a maze. And similarities test, where 14 apparently dissimilar words pairs are given and the link must be deduced. Clearly, these skills overlap. Regardless, occupational health test battery selections must give consideration to a breadth so that a potential deficit effect is not missed, and practicality of administration, particularly if the testing is to be undertaken at the worksite to enable monitoring of immediate effects of exposure. Selection should also include tests which reflect skills not likely to be affected by the toxin, or hold tests. Tests which give an indication of the native ability. Tests which enable a differential diagnosis, that is, they exclude effects from dementia or psychiatric conditions, and tests which are developmentally appropriate to the particular population. Principles of test administration. While neuropsychological testing is a specialist skill, the OHS practitioner may at times be required to assist with workplace-related test interpretation or selection. In order for a new psychological test to be appropriate to use, it must have withstood rigour in its development, such that the result can actually be said to be measuring what it says it will measure. Tests which require multiple cognitive skills do not enable specific conclusions to be drawn if a person has difficulty in understanding the task. For example, a task that requires you to listen and repeat words requires auditory acuity, auditory attention and discrimination, concentration, and auditory memory. Furthermore, skills in task completion is influenced by confidence and familiarity with having undertaken similar listening tasks. Poor performance in this task could be due to difficulties with any one of these domains. To determine what is poor performance, the test must have a suitable normed results, so that an individual's performance can be compared with the expected result based on a large population of normal people within a particular age group, if this is relevant. A normal person is defined as a range of values taking into consideration the natural variation in the skills of people. Results outside this reference range are then regarded as indicating a deficit in this skill area. Often testing with populations known to have certain brain impairments confirms this. The greater the numbers and the broader the selection of people used to establish the norm, the greater the confidence with which conclusions about abnormality can be drawn. For example, an individual should not be able to be labelled as outside the normal range in a cognitive skill due to nerves, reluctance, poor literacy, poor vision, or tiredness on the day. In this respect, a valid result can be retained. Tests must be also reliable or able to be repeated by different people at different times and generate the same result. The next imperative element of psychological testing is the confidence with which we can be sure that the test was undertaken and evaluated in the same way by each person tested, i.e. that it is a standardised test. For these reasons, neuropsychological testing has been restricted to specialists in the field so that the testing and test conclusions are meaningful. This has also served to limit its use in the occupational health setting. Test selection, as distinct from the clinical setting, needs to involve a trained neuropsychologist and an informed occupational health practitioner who understands the hazards and exposure characteristics. Risk management. Again, as in previous modules, the fundamental concepts of risk management apply for the management of hazardous neurotoxic exposures in the workplace. First of all, risk identification, risk assessment, and risk control. Now, this will also include the quantification of the hazardous exposures using exposure standards, material or safety data sheets, and other prescriptive tools, and the development of appropriate controls. In Module 5, the reading from Edwards and Benke addressed some of the complexities of exposure assessment and the establishment of ill health causal relationships. What we said was that to investigate occupational exposure ill health causal relationships, you need to be able to identify or measure each and all stressing agents in isolation, to collect information about the body response to every presenting hazard in a work situation, clear information about the relationship between the existing hazards and the worker's actual level of exposures, clear information about interactions between multiple hazards and their harmful effects, to understand potential dose and response and the strengths of potential causal relationships, to assess the multiple causes of disease, including factors external to the workplace hazards, and importantly, to establish a history which considers and includes time factors, damage factors, and dose factors. And it's also essential to have a good knowledge of what neurotoxins are present in the workplace, what level of exposure to these neurotoxins constitutes a risk, and for each hazardous exposure, how to implement and manage procedures to monitor the workplace and control the workers' exposures. Now, this is the list of references which we've drawn on to create these lectures. Thank you very much. Goodbye.